All right, in this video, we are going to be talking about geometric series and what they are. I'm not going to go over this because this is pre-calc material, so hopefully just skim over this in terms of what you need to remember. The most important part is going to be what a geometric series looks like in terms of my little formula right here. So we'll always have a first term, and then we'll always have whatever my common ratio is. So in this case, it's going to be my formula when r is between 0 and 1 is my first term, and then over 1 minus my common ratio. We have properties, once again, very similar to every other property that we have so far. Same idea. All right. So for number 1, what we are going to do is determine whether each series converge or diverge. Remember, even though I didn't say it right here, an infinite series is the sum of the sequences. So in this case, we're going to add 3/10 plus 3 over 100 plus 3 over 1,000 plus 3 over 10,000 plus 3 over 100,000 and so forth. So first, we know that I have my first term being 3/10, and then I kind of need to figure out what my common ratio is. So you'll see that my common ratio, if I were to multiply to get my next term, is 1/10. Using my handy dandy formula, I have 3/10 over 1 minus 1/10. If you want to leave it like that and call it a day, you can. However, on the MCQ, you probably will not see that, but instead you'll probably see 1/3. Same thing with number 2. You know that your first term is 5. And then if I were to look at my common ratio, this is going to be 1. The top is being multiplied by 2. The bottom is being multiplied by 3. And then since my signs are alternating, negative, positive, you know that my common ratio is negative 2/3. Now, because my common ratio is negative 2/3, and I'm taking the absolute value, and it's between 0 and 1, we know that this series will converge to some number. What number? Let's find out. So I have a sub 1, and then 1 plus 2/3. That is going to be equivalent to 5/3. That's going to be equivalent to 3. So this means that this series will converge to 3. Number 3 is a little bit different. So you can see 1/3 plus 2/9 plus 1 over 27 plus 2 over 81 plus 2 over 1 over 243 plus 2 over 729. And what I want you guys to do is probably think about what can I do in terms of, let's say, one of the properties that I have. Okay, so as you look at the properties, we could probably use the second property right here where we have the sum of the first series and then sum of the second series. Since I only have one series right here, I'm going to try to split this up into 2 series. What I'm going to do is split it up so that my numerator all has 1 or my numerator all has 2. You'll notice that here, my first term is going to be 3, and then my common ratio is 1/9. Since 1/9 is less than 1, we know that this is going to converge for this part right here. Same thing for the bottom part. My first term is 2/9. My common ratio is also 1/9. So we know that that's going to converge. Since both of these series will converge, we know that the whole series right here will converge to some number. What number? Let's find that out. So I have 3 minus 1 over 9, 2/9, 1 minus 1/9, which can be rewritten as 3 plus 2/9 all over 8/9, which then again, 3 can be rewritten in terms of No, wait, that's not 3. Sorry, that's 1/3. That's why I was thinking, Okay, 1/3, so that's going to be 3/9. So 3/9 plus 2/9 is 5/9. 5/9 over 8/9 is the same thing as 5/8. Now these examples right here where we had to find the common ratio and find the first term, you'll probably see a couple of these, but most likely you'll see it in summation notation, and you'll see it in a more complicated way-ish in terms of how they are seen. All right, so looking at number 5, we have the summation from n is equal to 1 to infinity of 2 to the n times 3 to the 1 minus n. You want to be careful in terms of what your starting value is. Because your starting value is at 1, your little sequence needs to be a sub 1 times r to the n minus 1. Now number 6, because your sequence, your series starts at 0, your formula is going to be a sub 0 r to the n. So whatever your starting term is, or your starting series, you want to make sure that this matches up with the exponent. All right, so I have this nasty looking thing right here, and I need to make it so that it looks like this lovely thing right here. What I'm going to do now is think about how I could change 2 to the second power to be 4 to the n, and then I have 3 to the 1, and then 3 to the negative n. All right. So if I were to clean this up a little bit, I'm going to have 3 from this 3 right here. Then I'm going to have 4 to the n, and then 3 to the n, which means that I have 3, and then 4/3 to the n. And now, my numbers do not match up. This is a 1 and this is a 0. So what I'm going to do here is think about how can I make this to be n minus 1. And in order to do that, I'm going to multiply by the reciprocal. Because essentially what we're going to do is try to do this to get n minus 1. So then I'm going to multiply by 3/4. And that's going to give me 9/4. And minus 1. Now, here's the bad part. We did all of that work to find out that my r value is 4/3. And honestly, you could have stopped right here. Oops. Right here. Because your r value was 4/3, and that's greater than 1. Because your r value is greater than 1, this tells me that my series right here is divergent. Sad. All right. For number 6, notice how here my numbers match up. This is a 0 and this is a 0. Since my ratio is between 0 and 1 in terms of my absolute value, we know that works. So now we just got to figure out what my formula is. My formula is going to be the first term. And whenever I'm talking about first term, it's not necessarily the first term, but it's whatever you're starting out with. In this case, I'm starting out with my 0th term. So this is going to be my 0th term, or in this case, 2. And then 1 minus negative 2/3. So I have 2, and then 1 plus 2/3, 2, 5/3, so 2 times 3/5, or 6/5. All right. All right. Same thing for number 10 right here. Because I have a 0 right here, I want to make sure that this is an n and this is an n. So what I'm going to do is split this up so that I have 5 to the n, 5 square, 4 to the n, 4 to the negative 1. You'll see that I have 5/4 to the n, and then I have 5 square, 4 to the negative 1. I really don't care about this because you'll see that here my common ratio is 5/4. Since my common ratio is 5/4 and it's greater than 1, this tells me that this series right here will eventually diverge. All right. In class, if we have time, we would do 11 because this is going to be partial fractions. And this is going to be the telescopic series that is essentially the next lesson. But that's why it's this preview of next lesson. It's a good review on how to break this up using partial fractions because you're going to see partial fractions in this unit. All right. In the next video, we are going to talk about the telescopic test, the nth term test, and then the integral test.